Hello, it's the second lesson, and today's topic is a vector. A vector is a quantity that's characterized by numerical value and direction, in addition folded according to the parallelogram rule. The last remark is very important, since there are quantities that are numerical value and direction, however, are added differently than vectors, like pseudovectors. The numerical value of a vector is called its modules. This module gives the length of the vector. This is already the value, polar, and always positive. In the drawings, vectors are depicted as straight lines. A regular letter is used to designate a module vector. Sometimes a module is used to refer to the symbol. Vectors directed along parallel lines in the same direction or in opposite directions are called collinear. Vectors that lie in parallel planes are called coplanar. Through parallel translation, collinear vectors can be located along the same straight line, and coplanar vectors can be reduced to one plane. For three vectors, the following is true definition of equality of two vectors. They are collinear, have the same direction, and match their modules. Next, let's talk about the addition and subtraction methods of the vectors. Vector addition is too convenient to do, like start the second vector to coincide with the end of the first, and then drop from the beginning of the first to the end of the second, the resulting vector. The same is achieved by building the parallelogram, as you can see from the two pictures. The difference of two vectors a and b is called such a vector, c, which in sum with vector b gives vector a. So, multiplying a vector by a scalar. As a result of multiplication vector to a scalar, a new vector alpha is obtained, whose modulus is alpha times greater than the modulus of the vector a. So you can see the formula in the picture. The direction of the vector b is either assumed with the direction of the vector a, where alpha is greater than 0, or a counter-rectangular vector a, where alpha is less than 0. So now let's talk about the linear relationship between vectors. Consider three non-collinear vectors a, b, and c, which lie in the same plane. Any of them, for example c, can be expressed in terms of other two vectors using the ratio c equals a times alpha plus b times beta, where alpha and beta are some numbers. Thus, any vector lying in one c planes with non-collinear vectors a and b can be expressed in terms of these vectors with linear relationship. There are three vectors a, b, and c, each of which is non-coplanar with the other two. The fact that the two vectors are always coplanar follows from the fact that by parallel transfer it's always possible to combine them beginning and then they will be located in one plane. By analogy with the previously given example, any vector d can be represented as a linear combination of a given vector, as it's given in the formula. D equals a times alpha plus b times beta plus c times y. For fixed vectors, any vector a, b, c, or d is uniquely determined by three quantities, each of which can be either positive or negative. Projection of the vector. Consider some direction in space, which we define as the axis L. Let the vector a form an angle phi with the axis L. Value AL equals a times cosinus phi, where a is the module of the vector. The vector projection is an algebraic quantity. If the vector forms with the given direction an acute angle, then cosinus phi is greater than 0, so the projection is positive. If the angle phi is obtuse and therefore cosinus phi is less than 0, the projection would be negative. When the vector is perpendicular to the given axis, the projection is 0. So now, let's talk about the radius vector. Radius vector r of some point is called the vector drawn from the origin to this point. Its projections on the coordinate axis are equal to the Cartesian coordinates of this point. So Rx equals to x, Ry equals to y, and Rz equals to z in the picture. Therefore, in accordance with the first formula, the radius vector can be present in the form of R equals to x multiplied by ex plus y multiplied by ey plus z multiplied ez. However, according to the second formula, r squared equals to x squared plus y squared plus z squared. Scalar product of vectors. Two vectors a and b can be multiplied by each other in two ways, either come to a scalar value or get a new vector. Therefore, the two products of the sector are distinguished as scalar and vector. There is no vector by vector division operation. So,
Dot product of vectors a and b is called a scalar equal to the product of the modules of these vectors per cosine alpha of the angle between them. So AB equals to AB multiplied by cosine alpha. Vector product. Vector product of A and B is called the vector C, defined by formula. C vector equals to AB multiplied by sinus alpha and multiplied by n, where A and B are the models of the multiplied vectors, alpha is the angle between vectors, and n is the unit of the vector of the normal to the plane in which it lies between A and B. So the direction is chosen so that sequence of vector A, B, and n form the right screw system, the rule of 3 fingers on the right hand. This means that if you look after the vector, then n turns made along the shortest path from the first vector to the second is carried out of clockwise arrow. The figure, the n vector is directed beyond the drawing C and depicted as a circle with a cross. Direction matches the direction of n. So keep in mind that the vector product will be a pseudo-vector only if both multiplied vectors are true, or both are pseudo-vectors. The vector product of a true vector by the pseudo-vector will be true vector. Change the condition that determines the direction of pseudo-vectors, the opposite will lead in the case to a sign change in front of the vector product, and simultaneously to a sign change in front of the one of the factors. As a result, the value expressed by the vector product will remain unchanged. Since the direction of the cross product determined by the direction of a rotation from the first factor to the second, the result of the vector multiplication depends on the order of the factors. Permutation of the factors causes the change direction of the resulting vector to opposite. Thus, the vector product doesn't have commutativity property. So the vector product is distributive, as you can see in the formula. So now, double vector product. Consider the double cross product of 3 vectors, A, B, and C. Any vector product is perpendicular to both factors, therefore the vector G is perpendicular to polar to the vector n to determine the direction vector of BC. This implies that the vector G lies on the plane formed by the vector B and C, and therefore can be represented as a linear combination of these vectors. D vector equals to alpha times beta vector plus beta times C vector. So that's the end of today's lesson. I think you gained enough knowledge. See you in the next lesson. Goodbye.